All right. Well, 20 minutes past the hour. Um, Apologies for that. I had actually had another meeting that ran over this morning. Go grab some water. All right, so today's our second lesson on sort of an introduction to Java objects. Yesterday we looked at, so objects in Java allow us to extend the type system, allow us to create our own custom types, and also allow us, with those custom types, to both store information and implement sort of algorithms attached to that information. And so yesterday we looked at objects primarily as sort of containers for information. And today what we're going to do is we're going to look at objects, we're going to look at object methods. And so yesterday we looked at how do we store data using new types of classes. So that allows us to kind of like bundle together multiple fields of different types into a single data point, which is really appropriate when we work with different types of data. But that's only really half, maybe even not half, maybe only like a quarter of the power of Java objects. Because I can also, an object definition can include both fields, both things that store data, and methods, things that implement algorithms, and the methods act and can act and utilize and modify the data that's stored on the object. And so that's kind of like where you get this really cool synergy bringing these two things together. So and we can, what I'd like to do today is ask, answer as many questions as possible. But let's look at, we'll just look at the example that's on the cover sheet, where we lead off the top of the lesson. So yesterday we looked at examples like this where, I had a dimensions class, for example. So yesterday the code would have looked like this. I'll comment out the rest of this. And let's go through this very carefully. So I've got this new class keyword, and this is what defines a new type in Java. This is a new type of object. It's a new type of data. I can use this, once I define this class, I can use it like any other type. I can use it, attach it to a variable. I can save data into it, which in ways that we'll look at. But that's what the keyword class does. It says, okay, I'm about to define a new type of data in Java, a new type of object. I get to name it. We choose by convention names with capital letters for Java object types. We know about the 8 primitive types. Those have lowercase letters. We've been working with strings with have an uppercase letter because strings are in fact objects. So this starts with a capital letter. That means I'm about to, that's the name I chose. I can choose lowercase letters, but we're using Chuck style to enforce this. It's very, very conventional in Java to do this. So this is just kind of the right way to do it. You choose a capital letter for your class names. Then I have a block here, right, between these two braces. And going back and sort of reviewing from yesterday, this block is very different than the blocks we've used in the past. This is not a method definition where there's code in here that's going to be executed. This is really more of a declaration. It's more of it defines what the class the type of data can store, the fields, which I have 2 fields here right now. I have a width, which is a double, and a height, which is a double. But it also describes what the class can do, and that's what's new today. And so what we saw yesterday was that my class declaration, what is enclosed in these curly braces, can include 1 or 2 or sometimes 0, but usually 1 or more fields. These fields store individual pieces of data, and a single instance of a dimensions will have both a field called width that I've named that stores data of type double, and a field called height that stores data of type double. And these can be any type. This could be an array, it could be a string, it could be a 2-dimensional array. I mean, it's not appropriate for this particular type of data, but these fields can be any one of the types that you know. And once we start to create objects, we can actually create fields that have the type of the new objects that we've created, right? So we might have a room that has like a field dimensions, and we'll look at how to do that a little bit later. So this is what we did yesterday. And yesterday what we were able to do is do stuff like this, right? So let's go through this code again line by line, slowly, one bit at a time. Line 5, I have an assignment. I see the assignment operator. Let's look at both halves of it. So on the left side, this is the thing I'm assigning to. Remember, we work from right to left with assignments. I have a variable called room, and you'll see over here that I've given it the type dimensions. And I can do that because I just defined this new type up here. If I comment that out, you'll see that Java doesn't know anything about this particular type by default. This is not a type that's built into Java. When we use string, it was just there because Java comes with strings built in. But this dimensions class is new, so I have to define it before I can use it. Once I've defined it, now I can use it as a type. So this appears in the place where I would see int or string or long in our previous variable declarations. So the left side looks familiar. I've got the variable type, dimensions, if I got the variable name, room, and then I'm going to do an assignment. And so what is on the right side of this assignment operator needs to be something that I can save into a variable of type dimensions. And this is, again, a little bit of a new piece of syntax, literally new, that I love making that joke and make it every year. Literally new that we saw yesterday, where the way I create a new instance of a class is I use the new keyword. So I use new, and then I have the name of the class. And this is one of these things that's not going to make perfect sense to us until tomorrow when we actually talk a little bit about what are called object constructors. But this looks like it's a method call. It is a method call. Why that's happening, again, we'll get there. We'll talk about this just tomorrow, right? I'll have a whole lesson about this, and then this will start making more sense. But for now, I say new, name of the class, open, close, parentheses, and what this will produce is a new instance of that class. So again, review from yesterday, instance, class describes a particular category of things. So, cat is a class, right? Be all mad. She's all angry with me because I just woke her up from a nap. So this is an instance of a cat. This is Ziz. No, Grumpy. You were sleeping, right? Okay, go back to sleep. I wish I got to sleep as much as she does. So cat is a category. Ziz is an example, an instance. She's an actual cat. There's this idea of an abstract cat, right? Biologists have a precise definition. There's a family called Felidae, and there's a specific, types of cat, right, that they have identified based on, I don't know how they do this, but the idea is they've studied animals and they've come up with some classification, categorization. So there is something and she's like a Felidae domesticae, I think. It's a domestic cat. That's a particular kind of cat. There are other kinds of cats. Lions, tigers are cats and I like to think of her that way, like she's a little lion. Anyway, the point is that the class is a category. It's not a specific thing. There's no there are cats, but there's no thing that is the cat. There are just individual cats. Some of them have names, some don't. She's an instance of a cat. So when I use the new keyword, what Java does is it creates a new instance of that class. If I don't see new, I don't have a new instance. So until I called new, or I used the new keyword on line 5, Java knew what it meant for something to be a dimensions object, but I hadn't created any. I get to line 5. On the left side, I've set up a variable that's going to store this new object, and on the right side, I use new to create one. So now I actually have an instance of dimensions that's called room. And because of how I've defined the dimensions class as having a width and a height as properties or fields that are both doubles, I can use dot notation to set these values, and I can also use dot notation to retrieve them, like if I wanted to print the width. Okay, so this is sort of a review from yesterday. Now let's look at how to add a method. So how do I add a method to my declaration? Well, what I do is I go up here into the type declaration or the class declaration itself, and I'm going to add what looks very much, so when we've written methods, we've written things like, double, if I wanted to write this method, I would do something like this, right? And then I would say return width times height. And I can do this actually. And so what I could do is I could do this. I could call it area with room dot width room dot height. And you'll see that it does the right thing. But so this is one way of doing things. But here's the thing, it would be nicer if that, every time I had a dimensions object, it knew how to calculate its own area without me having to call this function and pass, all this information to it. And so what we're going to do is we're going to take this method declaration that looks familiar to us that we've seen outside a class definition, and we're going to move it inside. Okay, I'm going to do this, do that. And so that's one of the changes. I can list 1, 2, 10, 0 different methods that are inside this class. Now the first thing that changes is now I have to call this differently. So I have to use dot notation to call it. Oh, sorry. Checks out. We'll explain this error message later, but for now let's just change this so the parameters to this method aren't named names that conflict with the fields. So I can do this and it works, okay? So that's the first thing is that when I move it inside the class declaration, I now have to use dot notation to call it, because this is now a method that in order to call, I need to call it on an instance of this particular class. Right now I'm not taking advantage of that, but I'm about to do the next thing that I can do with an instance method, which is that I don't need you to tell me what my width and height are. I already know that. The method is now part of the class definition, and as part of the class definition, it can access the variables or fields, the instance variables or fields that are defined on the class. And you'll see now this works. And so that's kind of our journey, right? Like we've used variables, we've used methods. Now we're bringing them into one place. And the big conceptual shift with object methods is that they have access to the values, to the fields that are declared as part of the object, and also to their values. And you'll see, like, doesn't this look nice? It's just like, pretty, beautiful, right? Concise, right? Before it was like I had to have this separate method that had to be located somewhere, and then I had to pass all this extra information to it. Now, anywhere I have a dimensions object, if I need to compute the area, I just call dimensions object.area. Let's look at, and this is another stumbling block for people. So now let's do this again, but let's create a new room, and let's call this kitchen. And we'll set this room up a little bit differently. So its dimensions are different. And now I'm going to, what did I do? Oh, I'm still setting them on room. I have to be careful here. This is going to get so much nicer tomorrow when we talk about constructors. But for now, this is how we're doing things. Okay, check that out. So now what's happening? And so this is, it may feel like I'm going through this stuff like at a glacial pace, but there are some very big conceptual jumps here that we need to kind of go through and that you need to understand. So every time in this piece of code, what's happening? So this part we already went through. I created an instance of dimensions on line 8, and I stored it into a variable called room. I set its width and height using dot notation, which I can do because every dimensions object has a width and a height. And then I called this area method, again using dot notation, because every dimensions object has an area method. Now inside this area method, let's come back and talk about this for a minute. You see something that might look alarming, because you might see this. Again, if I wrote this function, let's take this function and put it outside of the class definition and fix the check style errors that I'm going to get in trouble for. Now you'll see, oh no, there's a problem. So I couldn't write this method this way before because it doesn't take any parameters. And so the question is, where is this variable coming from? There's no variable called width that this method has access to. Once I put it inside the class definition, now it can access the fields that are defined on that class. And so when I call area or any other method that I define on a dimensions in the dimensions class, I can access width and height, and I access the current values of that instance of dimensions. And that's what this example is designed to help us understand. So here I set up a dimensions object, and I'm calling it room, and then I set its width and height to 8.8 and 10, and then I call room.area. So when room.area runs, and I can put in a print statement here, we'll say, how about width plus width, and then plus height plus height. So we'll put a print statement here to see what's happening. So the first time when I call room.area on line 13, I enter the function just the way I normally would, and you'll see that width and height are already defined, despite the fact they're not parameters to the method, and they have the values that I've set on that instance of the dimensions object. So I created one instance of the class dimensions, and then I set its width and height. And when I call this method, width prints 8, height 8.8, height prints 10, because those are the current values of the width and height for room. Now down here at the end, I create another dimensions object called kitchen, which is different. So kitchen and room are the same type of thing, but they can have different properties. So again, it's like having two different cats, right? Like one cat might be taller and one cat might be heavier, right? There are different things that we can measure about each cat. They don't have to be the same, right? If I feed one cat too much and it gets really fat, the other cat's fine, right? In fact, if you had two cats, one might be in other's food, and so the one gets really big, the other gets really small. I don't know, right? But the point is that each instance of the class can have its own attribute values, right? So each one of these instance variables that I've defined up here can have an independent value for any instance of dimensions. They're not connected to each other at all. So when I create my kitchen object down here, or my kitchen instance of the dimensions class, I set its width and height to values that are different than room, and then I print its area. And so when this area method runs, you'll see that the width and the height that are printed are different, and the width and the height that are printed are the width and heights associated with the kitchen instance of the dimensions class. Now let's print off, just for fun, just to make sure that, you know, I'm not lying to you and nothing has changed about room. I haven't changed, oh gosh, I need some spaces here. I haven't changed room at all down on here. None of this code touches my room object. I'm working with kitchen. And so when I got down here and print room.area, you'll see that the width and height of room are the same as they were when I printed it on line 13. And so, you know, I get the same result. I can change the value of room.width. So let's say I set the value of room.the width to something different, then I get a different result. And so, you know, this is a small example of things to come. A small example of the type of work that we're going to do over the next couple of lessons on various types of work with object design. But this example already really sort of, you know, brings together the core concepts that we're going to be discussing over the next few weeks, right? This idea that, so a couple of key ideas here before I will just throw the floor open for questions. The class keyword allows me to create a new type of data, a new type of Java object. That type of Java object really, and we'll talk more about some of the details, but fundamentally consists of two different things, right? So these are fields or instance variables. These look like the variable declarations that we've been talking about. This is how each instance of dimensions stores information. So, you know, what I'm saying here is that each instance of dimensions will have a width and a height, and both of those are single double values. And so every time I create a dimensions object, I can access its width and height using dot notation and set those to any double value. I can't set it to a string, right? So if I try this, you know, this is not going to work because Java is going to make sure that the right side of this assignment matches the type of the left side. The type of room.width is double. The type of the right side has to be something that either is a double or it can be converted to a double, and I can convert it into a double, but I can also use something like this. Okay, so that's the first part of my class definition. The second part is what we sometimes call instance methods. And these look like method declarations that we've written before. I've got the return type here. I've got a name. I have a parameter list, and I can pass parameters to these. And one of the walkthroughs that's down farther in the lesson actually goes through that, right? And it gives you an example of actually passing parameters to a method in addition to the data that's already stored on the method. And then I have the body of the method. And so this method was declared to return double. It has to return a double. Along the way, it also prints something. That's something that we added just sort of for debugging. Now, again, the really big, important conceptual change here is that these object instance methods if a method is defined as part of a class declaration, it has access to the instance variables that are also part of the class, those fields on line 3 and 4. It can modify them, it can read them, it can use them as part of the computation. And so what's weird here is that, if we think about the method declarations we wrote before, we would have had to pass a width and a height to this method somehow as parameters. Now I don't have to. Now I can access them because this method is also part of the same class. Okay, so that is today's lesson. Again, a little bit of a smaller lesson. You can think of yesterday's and today's as kind of consistent of one chunk of new content. But I do want to take some time with this material to make sure that we really get some of the basics down. Things are going to get more complicated, but this is really it, right? This is the last 2 lessons. What we've really done is introduce you to kind of the big conceptual leap forward that objects represent. There's nothing tricky here, right? I mean, you guys wrote an area method in the 3rd day of class, right? So it's not like this is a hard method to write. I'm not asking you to implement encryption or something like that. What's tricky here is getting your mind wrapped around some of the concepts that are going on. The new types, the access, how everything works together, how the type binds together various properties and methods and stuff like that. So that's what's really new. All right, I'll hang around for probably about 10-15 minutes to see if there are any questions about this. Happy to do some more examples. We can look at examples of multiple classes. We can write some more instance methods if you guys want to look at that. But this is sort of where we are at this point. And this is an exciting place to be because on some level, programming and being a computer scientist are about being a creative, right? I really hate some of the stereotypes of computer science as this field is just sort of drudgery and programming is boring and stuff like that. This is, on some level, the purest form of creation, right? There was that quote from Fred Brooks, right, that we looked at about, the programmer is, works in pure thought stuff, right? And when you start being able to use features like this in a language like Java, you really are creating castles in the air, right? You are now the designer. Now, when we ask you to do things for this class, particularly on the homework problems, we're usually going to give you pretty specific instructions because we need to agree on how things work. So if we're going to test a class that you wrote, which we'll start doing tomorrow on new homework problems, we need it to have particular methods and particular fields and stuff like that, and they have to be named in a certain way so that our test suite knows what to expect. But what I'm showing you here is a path forward to just sort of ultimate creativity as a programmer and as a computer scientist, because once you start building your own things, you do it your way, right? You can call things what you want, you can design your objects the way you want, you can design them to model whatever you want to do. You get to make these choices. You get to figure out what fields are needed. You get to decide how the methods work and which ones you implement. And what's cool about Java is the language supports all this, right? This is almost like we can now mod Java, right? We don't have to be content with what Java gave us out of the box because that's far from sufficient to solving most problems that we would want to solve. Instead, we're going to create our own types and we're going to use them to solve our own problems. And, again, this is and we'll talk a little bit a couple lessons from now, we'll go through some examples of object modeling where we actually pick a real problem, design a few classes to store data that's appropriate to that problem, and work through an example of a program that uses several of those classes and how they might interact with each other and stuff like that. But that's where we're headed. All right, questions. I'll hang around for just a couple of minutes. To see if people have any questions that they want to ask. I'm happy to help. you guys are stoning me. No one has a question? Anything? Used to say to students that part of one of the things I had to learn in my job is the art of enduring long, awkward silences, since I would be up in front of the class and I would ask a question and I would, just have to wait. But it's easier now because I can do other things, but I am here. I'll hang out for like 5 more minutes or so. If you guys have questions or concerns, stuff that you want to chat about, throw it up in the chat and we'll take it up together. Midterm covers everything covered through Friday. Yep, not yesterday's material or today's material, but everything up through Friday. So, what are we doing Friday? Cert, everything from last week. Yeah. If you haven't taken the midterm yet, I wish you the best of luck. It seems to be going quite smoothly so far. So, happily, none of the technical glitches that plagued us the first time through. So, I am extremely relieved by that. It was not a fun morning. All right, well, it's good to see all you guys. We got tomorrow. Tomorrow we have a homework problem. Midterm will be behind us. Put that in the books. Maybe tomorrow we'll talk a little bit if you're curious about kind of how to interpret your midterm score. But yeah, we're going to move on. We've got a lot of exciting things to do this semester, and I look forward to seeing you all tomorrow.